Okay, today's lesson is about 30, 60, 90 right triangles. And you should have this worksheet in front of you. This video is going to go with this worksheet. At times you're going to be filling in information with your groups, and at times we're going to be going through some examples together on this video. So at this point, what I want you to do is I want you to pause this video and do numbers 1 through 5 with the people sitting at your table. Okay, so you should have information filled in for sections 1 through 5. You should have realized that this is an equilateral triangle. It's also an equiangular triangle. And this segment, TE, is an angle bisector, an altitude, a median, and a perpendicular bisector. So angle 1 is congruent to angle 2, and these two segments are both 3. Then, using the Pythagorean theorem, you should have found the length of TE. You had to simplify a radical. You're going to end up with the square root of 27, which is the same thing as the square root of 9 times 3, which is the square root of 9 times the square root of 3. And if the square root of 9 is 3, and then just times the square root of 3. You should have also realized that the hypotenuse is always opposite the 90-degree angle. The shortest side is opposite the smallest angle. The middle side is just going to be across from the angle in between. The short leg in this example is ES, the long leg is TE, and the hypotenuse is TS. So at this point, I want you to pause the video, and I want you to go to number 6, where you're supposed to use the Pythagorean theorem to find the lengths of the missing sides of triangles A, B, and C. Record your data in the chart below. So once you get your data recorded, we can start up the video again and check your answers. This should not take you more than 10 minutes. Okay, so the data for the triangles, when you solve them for the Pythagorean theorem, the side lengths are filled in the table below. You can see I have 6, 4, and 15. 6 square root of 3, 4 square root of 3, and 15 square root of 3, and then 12, 8, and 30. So you should have these data. If you didn't get these exact answers, let's record them now, and we'll continue to practice simplifying radicals. The next section I want you to do is section 7. You're going to make a conjecture about the relationship between the short leg with a length n and the long leg and the hypotenuse, and then label the sides of the triangle on the back of this worksheet. So what you're going to do is you're going to assume this short leg has a length of n. And then you're going to look at the pattern that you may see here, or you should see here, and tell me what the long leg and the hypotenuse is in terms of n, and label the triangle on the back. So pause the video here, and then we'll come back and explain the 30, 60, 90 triangle. All right, you should have the lengths of the sides of the 30, 60, 90 triangle labeled n for the short side, and this isn't exactly drawn to scale, so it looks a little bit out of whack. 2n for the hypotenuse, and n square root of 3 for the length of the side opposite the 60-degree angle, which is called the long leg. Now, we have a process for solving 30, 60, 90 triangles. It's very similar to the process we used to solve the isosceles right triangle, or the 45, 45, 90 triangle. In this case, I want you to always consider the short leg, or n, your home base. And the thing about solving 30, 60, 90 triangles is you're always going to come back to your home base first before going on to another side. So for example, if I have the length of the hypotenuse and I want to find the length of the long leg, I have to come back to my home base first, and I would do that by dividing by 2. Then, if I want to go from my short leg to get to my long leg, I would get that number by multiplying by the square root of 3. It also works the other way. If I have my long leg and I want to find my hypotenuse first, I go back to my short leg, divide by the square root of 3. If I have my hypotenuse, I want to find my long leg, but I have to come back to my short leg first, If I have my short leg and I want to get to my hypotenuse, I'm going to multiply by 2. So if you treat the short leg as your home base, all you're going to ever have to do is multiply or divide by 2, or multiply and divide by the square root of 3. So pause the video here and make sure that you get this written down, and then we'll solve some examples for your notes below. For examples 11 through 14, I've already labeled the missing sides, and in this example, I labeled your sides n2 and an n squared of 3. In this example, I need to find the length of my short leg. Well, I have my hypotenuse, and to get from my hypotenuse to my short leg, I divide by 2, so this would be 18. Now it's not so difficult to find the length of the long leg because I just take the short leg and multiply by the square root of 3. So that would be 18 square root of 3. In this example, I have my long leg. To get from my long leg back to my home base, I divide by the square root of 3. So this just becomes 12 because the square root of 3 is canceled. Then I multiply by 2 to get 24 for the hypotenuse. I know I'm going fast, so just keep up with me and get these notes written down. After we do a few examples, it'll start becoming clear to you. Okay, my short leg is 15 square root of 3. To get to my hypotenuse, I multiply by 2. 15 times 2 is 30, and you just leave the square root of 3. To get from my short leg to my long leg, I multiply by the square root of 3, and 15 times the square root of 3 times the square root of 3 is the same as 15 times 3, because the square root of 3 times the square root of 3 is 3. So this leg is 45 units long. In this case, I have my short leg. To get to my hypotenuse, I multiply 3 times 2 is 6. To get to my long leg, I just multiply by the square root of 3, and this is 3 square root of 3. You want to leave all your answers in simplified radical form. This actually is easier. So you want to pause the video here if you didn't get all this written down, and we'll go on to the next 4 examples. Okay, at this point I've solved the 15 and 16 because we're running out of time on the video. I only have 10 minutes on the video. So let's skip right to 17, and you can get this down when you pause the video at the end. Here I have a 30, 60, 90 triangle, and I'm given the length of the long leg. Even though it's not drawn to scale, this is the long leg because it's across from 60. So to get from here to my short leg, I'm going to divide by the square root of 3. So 12 divided by the square root of 3. If I rationalize my denominator, I have to multiply the top and the bottom by square root of 3, and I get 12 square root of 3 over 3, which is 4 square root of 3. So this side here is 4 square root of 3. If I want to get to my hypotenuse from my short leg, which is my home base, I multiply by 2. So this would be 8 square root of 3 because 2 times 4 is 8. This is an isosceles right triangle, so this leg is also 4 square root of 3. And to get from my leg to my hypotenuse of a 45, 45, 90 triangle, I multiply the 4 square root of 3 by the square root of 2, and that would be 4 square root of 6. This last quadrilateral, I actually drew in a 30, 60, 90 triangle, and this side, this segment is 6 square root of 3. These two are the same because they're between 2 parallel lines. This is my long leg. To get to my short leg, I divide by the square root of 3. So this is 6. And then I multiply by 2 to get to the hypotenuse. That's 12. If this piece is 12 and the whole thing is 21, then this piece is 15. So y is 15. So you should have enough information now to work on the homework. You're going to go back and forth between your notes and the homework, which is evaluate. If you have time in class, you should start in class and then finish the rest for homework. This video will be posted on the website, so you can always access it again if you have any questions. And I'll see you next time.